So the last thing we're going to look at in this section is a bit on the powers of the imaginary unit I, where because when you take that value I and square it, we've seen a whole bunch of times, you get -1, you might find yourself wondering what happens if you cube it, if you go to the fourth power, and so on. Where if you do that, if you get it cubed, you'd be taking -1, multiplying it by I, essentially, so you'd finally, after all the times I've said it, get -I. And then if you multiply that again by I to get I to the fourth, you'd have -I times I, which ends up being -1 times -1, or 1. So you have those 4 powers of I, and actually the thing is, once you go to the next power, the fifth power, that's really I to the fourth times I, which is just 1 times I, so you end up back at I to the first. And if you went to the sixth, you'd end up looking at I to the fifth times I, but you already know what I to the fifth is, you can get that one. And it really does follow that nice pattern that you can work with forever in terms of divisibility by 4, where in particular, if we want to talk about something like, say, I to the 73rd power, what we can do there is recognize that I to the 73rd is really I times I to the 72nd. I know, it's high-level stuff, just bear with me. And that is I times, well, I raised to the 4th power, raised to the 18th power. This is tough stuff so far. I know it's not obvious where I came up with that. But the thing is here, we want to reduce as much as we can to powers of 4. Because when we reduce to powers of 4, something really magical happens that we can see over there. We still have an I, but that is a 1. And even if I'm raising 1 to 18 powers, it's still just 1. So that's just I. The whole thing clears itself out really nicely. And this holds for any situation where you have powers of I. You can always reduce as long as you know essentially what your remainder is in terms of division by 4. And this idea here hints at 2 really fundamental combinatorial ideas. For those of you that take discrete math, you'll be seeing them again, where this idea of reduction around a specific multiplication and remainder scheme, that's a thing called modular arithmetic. And then also thinking of one value in terms of previous values, like when I thought about getting the 5th power in terms of the 4th power, is an idea called recursion. And those 2 things link together really well and hit on a bunch of other important topics that we're not going to see a whole lot of in this class because they're combinatorics things. We're more continuous in here. But like I said, it's nice to see some of those connections to other places with the complex values. And also, if you're curious, you can take full complex numbers, not just I, raise that to powers. But it's not so nice to do in terms of foiling and foiling and foiling and foiling and foiling. Although you could. Wouldn't want to spend an afternoon doing that, but you could. Instead, what you may see if you get to pre-calculus is that there's another way you can talk about these complex numbers in terms of angles instead. That lends itself a lot more nicely to dealing with powers. But those are things that only some of you will see in more than 4 months from now. For more immediate circumstances, we're going to be moving on to section 1.5, where we're going to be looking at our old friend, the quadratic. I'll see you in there.